So this is question 1. So you're asked which is a component of the Earth's atmosphere and which is plentiful in supply. You go to the colour code that's in plentiful supply. Two biggest gases that are in our atmosphere, nitrogen and oxygen. You can see that the area here is quite big. Next, you're asked why should the use of helium in birthday balloons be avoided. So if I look at helium, this is what it is. And just if I look at what colour it applies to, it's this. So the availability is seriously threatened, okay, in the next 100 years. So that's the answer there. The element indium is used in smartphones. Indium will be used up in 50 years. So some of you said to use your iPhones. Yes, that's not really what will prevent indium from being used up. To recycle phones, to upgrade your phone less often. If there's a problem with it, to repair it instead of actually just buying a new one, and just to sell old phones instead of just throwing them out. So any one of those there would get you those 3 marks. Question 2 then here is your positively charged proton for 3 marks, negatively charged electron 3 marks, neutron 3 marks. No charge. So you're asked here then to compare the charge and mass of an electron with the charge and mass of a proton. So an electron, as we know from up here, is negatively charged, whereas a proton is positively charged. So 3 each there for comparing those. And then your mass, my proton has a mass of 1 AMU, whereas my electron has a mass of 1 over 1840. So there are your 12 marks going there. Question 4 then, if we look at this, this is my atomic number. My atomic number is my number of protons. So straight away from that, I know I have 9 protons. So 3 marks here for 9. For every 9 protons are positive, I have 9 electrons are negative. They're always equals. So that means I have 9 negative electrons. To work out then my number of neutrons, my mass number is my number of protons and neutrons. So I've worked out that 9 are protons. So 9 plus what gives me 19? 10. So 3 marks here then for working out my neutron number is 10. Always my proton is located in the nucleus. Also neutrons are always located in the nucleus. And my electrons then are always outside the nucleus or orbit the shells or in the electron cloud. So any one of those would also get you 3 marks for that. The diagram shows an atom that has 7 positive subatomic particles, and that's the key to this question. That means if it has 7 positives, that means it has 7 protons. That is its atomic number. So the element that has an atomic number of 7, if I go to the periodic table that I attached at the back, I find my element with my atomic number of 7. As I can see here, that is nitrogen. Okay, so nitrogen there is the answer. 3 marks again for that. Question 6 then is an atom of sodium has an atomic number of, so I'll actually just do this down here, of 11 and a mass number of 23. You're asked how many protons does it contain. So this is my atomic number. My atomic number is my number of protons. 3 marks there for my protons. Here 23 is my mass number, and that's my number of protons and neutrons. So if I have 11 protons, 11 plus what gives 23? 11 plus 12. So 12 here. Next then you're asked to draw a model of the structure of the atom. So I put my 11 protons for 3 marks and my 12 neutrons inside the nucleus of the circle. My first electron, so that's 3, 6, and inside is 9. 3 further marks for 2 electrons. Remember, if I have 11 protons in any neutral atom, if I have 11 positives, I must have 11 negatives. My first shell can always only take 2. My second shell can always only take up to 8. That brings us to 10, and I need to fill 11, so I have 1 more electron in my outer shell. that in total was worth 18. So 3 for your protons, 3 for your neutrons, 3 for putting them inside your nucleus, 3 for 2 electrons on my first shell, 3 for 8 electrons in my second shell, and 3 for 1 electron in my outer shell. If I look here, I masked potassium has an atomic number of 19, so my symbol for potassium is 19, and a mass number of 39. My atomic number means I have 19 protons. For every 19 positives, I have the same number of electrons, or negative. And then I have 39 here, so that's my mass number, which is my number of protons and neutrons. I've worked out that 19 are protons, so 19 plus what gives 39? 20. Okay, so I need to fill in 19 electrons. So 2 in my first shell, I have 8 in my second shell, I have 8 in my third shell, and I have 1 in my outer shell. The marking scheme for that, getting 2 and 8 in your first 2 shells was 3 marks, and then getting 8 and the 1 was your second 3 marks, so 6 marks here. My electronic configuration then for potassium, 2 electrons in my first shell, shell is full, comma, 8 electrons in my second shell, 8 electrons in my third shell, 1 electron in my outer shell. Okay. Next here then we're asked how many neutrons are in the nucleus of a carbon-13 atom. So I'm told I have carbon, so I have to go to my periodic table, and carbon has an atomic number of 6, and I massed for carbon-13, so that means it has a mass number of 13. That means here I have my atomic number, which is 6 protons. This here is my mass number, which is my number of protons and neutrons. So 6 plus what gives me my mass number of 13? 7. Okay, so 7 there gets you 3 marks. Then you're asked to enter the missing words. Isotope here is the missing word for 3 marks. And then you're just asked to explain isotopes. As we can see here, they're atoms of the same element. They are both carbon. So they're atoms of the same element, but they have different mass numbers. So every element can have different mass numbers. So that's 3 marks for atoms of the same element and 3 marks for different mass numbers. You can also state due to different numbers of neutrons in the nucleus.